Hi, this is Tim from Tiger Astronomy, and I'm just going through a bit of a coding exercise today known as a code kata because I haven't written any code for about 3 or 4 weeks and I'm feeling a bit rusty, and I thought it would be worth filming this as I do it because I wanted to demonstrate how I do test first development. And if you've not tried it, it's kind of counterintuitive as to how or why you should do it. And it's actually, the thing to realize is it's not actually a testing methodology, it's actually a design methodology, and helps to foster good coding practices and really does push you in the direction of cleaner, better structured code. So anyway, let's try this and see how it works out. So I'm going to do the FizzBuzz Kata. So the object of the exercise here is to write a method that, given a number, returns either the number itself, or if the number is divisible by 3, then it returns fizz, and if the number is divisible by 5, then it returns buzz, and if the number is divisible by both 3 and 5, then it returns FizzBuzz. So it's a cute little children's game, but it's quite a good code kata. So we're going to write the tests first. So I'm using xunit.net to do this. I've just created a .NET Core class library to write this code in. And I've already added the xunit libraries from NuGet. So I'm going to start by writing a test, which has to be a public class. So we want to say numbers with no special properties return the number. Okay. And then, so let's make that a, in xunit you can have something called either a fact, which is a normal unit test, or a theory, which is a data-driven test. So I think we're going to have a theory here. We have to give it the theory attribute, and as you can see, that's not recognized. So I need to import, where are we? I will not have installed xunit, so I'll tell you what, let's look at my other window here. If we can just switch over to the unit test workspace, and you can see that I've already got some tests here in another. I did a prime factors code kata earlier, so we'll just collapse those down. But in here, in the FizzBuzz Kata, we will add the xunit.net package. So we want to look at, let's get it so you can see both sides of my screen. I'm working on 2 monitors, so this is kind of a crunched together version of my 2 monitors. And so we don't want to be looking at myget, we want to be looking at the actual NuGet repository. So we'll go there and then we'll browse and we'll just look for xunit.net install, and that starts to happen. And there we go. And we're done, so I can close the, or at least switch back to the test panel. Okay. Let's go back to the code editor. Okay, so we're done with NuGet. We can close that window. Okay, now we can import xunit theory attribute. Okay, good. Right, now this currently doesn't take any parameters. Now, xunit FizzBuzz public class. It's not a class, is it? It's a method. So it's public void. Public void. You can tell I'm a bit rusty. And then we say, okay, theory methods should have parameters. Now, we this is actually coming from a Roslyn analyzer that's installed by xunit when you download the NuGet package, and it really gives you some quite helpful tips. So we know we need a parameter here, so we're going to say int input. This is the number where we'll be checking, and then okay, Okay, theory method. So we need to give it some data to test. So we use the inline data attribute for that, inline data, and then we'll give it the number 1. And the result we expect to get is, oh, my keyboard's gone a bit funny. Let's just change that over. And the result we expect to get back is 1. And then we can just duplicate that, and if we give it a 2, we expect to get back 2. Okay. Now, why have we got red squigglies here? Because there's no matching method parameter for value 2. So again, this is the Roslyn analyzer for XUnit. It's giving us a prompt that we've had 2 pieces of data here, but we've only passed one of them into the method. So what happens is the test framework runs through these inline data attributes one at a time. Each time it runs the test, and it takes each item of data here and just passes them into as the parameters, matching by position. So the first parameter gets the first data item, second parameter gets the second data item, and so on. So we need a string for our second data item, and this is our expected result. Okay, so our test is going to be to take the input and pass it to our FizzBuzz method and check whether we got the expected result back. So result, so let's say actual result equals naming is always a difficult thing, but one particularly famous guy says, if in doubt, call it monkey. So we'll call it monkey for now and see what happens. So fizzbuzz.monkey of input. Perhaps a name will suggest itself in a minute. Okay. Now, obviously, this is currently a failing test because it doesn't compile, and that is considered a valid failing test in unit testing circles. So we need to perhaps create this fizzbuzz.monkey method, and it's going to be a static method, so we can't really do that at the moment. We'll perhaps need to do it manually, so I'll do it manually under here. So internal class FizzBuzz, open squiggly brackets, and then public static void monkey, which takes an integer called input, and it doesn't actually return void, it returns string, so string monkey. Okay, now what we will do as a placeholder is just return string.empty, because we have to do the simplest thing we can to make our test go green. And my where's the unit test workspace? Let's get them both up. So my tests currently are green, which is a bit odd because oh, we haven't made an assertion yet. You must see your unit test fail, otherwise you don't know that it's working properly. So the rule is red, green, refactor. You must see a red test, then do the simplest thing you can possible to make it go green. All sins are permitted. And then you refactor the code to make it look nice and do things properly and make sure it still stays green, which means that you haven't broken anything, which seems like a crazy way of doing things, but if you think about it, what you are doing is nailing down the behavior of the method before you actually write it properly, which kind of does make a lot of sense. Okay, now where are we? So we need to assert.equal expected result, and actual result. Okay, and that should make the test go red, hopefully. Now, as you can see, we've got red markers here. The X means that an exception was thrown on that line. The dot means that this line has been covered by a test, but the test has failed. And the arrow here means that this was the starting line of a test. And over here on the other side of the screen, in my test workspace, you can see the tests listed and exactly what's failed. And you can see that the test was run twice. And it was run once with input 1 and input 2 and the expected result of 1 and 2, but I can't actually stretch that any wider. If I click on one of these, you can see in the output here we expected 1, but the actual was an empty string, and that's a funny way of representing a empty string, but there we go. This test runner here I'm using is called ncrunch. It's not free. There are other test runners available which are free, including one built into Visual Studio, and or xunit.net comes with its own runner, but I really like ncrunch because I get this nice little chart down here at the bottom which tells me how many of my tests are failing or whether everything's okay, and I get this sort of risk/progress graph here which just lets me see what's going on at a glance without having to look at any details. And you'll notice that I haven't even saved this file yet, so ncrunch is smart enough to suck the changes out of the file that I haven't changed yet and run the unit tests on it, which is amazingly clever and really useful. So anyway, so now we've got an assertion which fails. Now we have to fix the test. So since we've got two tests, we can't simply return a constant value. That wouldn't make the test pass. So we actually need to just convert the number to a string and return it, and that should make the test pass. So we could say return input dot toString, and that test, if you look at ncrunch, is already running the test and it's gone green and we're passing. Everything's okay. So we now red green, we're now on the refactor stage, but there's not really any refactoring to do there because the code's really rather simple. We might think about a name for this. So yeah, FizzBuzz.execute perhaps. It's a bit more sensible than monkey, so rename that. I'm using ReSharper to do my refactoring. You don't actually have to have ReSharper, but again, it's one of those things that if you write more than a trivial amount of code, it as Uncle Bob Martin says, it makes Visual Studio almost usable, and I kind of agree with him. So let's call that execute. Okay. Well, let's call it get FizzBuzz string. Let's call it that. Get FizzBuzz string. Now then. Okay. So we've kind of exhausted that test, I think. So what about if we copy that and start a new theory, and this time we're going to test for 3 returns fizz, and so does 6 because they are both divisible by 3. Okay, so numbers divisible by 3 but not 5 return fizz. Okay, so we don't really need an expected result here because we know that it's going to return fizz, right? So we just need to pass in 3 and 6, and we don't need the expected result. So So we can assert that actual result equals fizz. Okay, and then now the first thing that happens is our test runs twice and fails both times, which is good. Red-green refactor, we need to see it go red. So expected 3. Wonder if we can zoom that. No, we can't. I'm sorry. Expected 3, actual fizz. We've got those the wrong way around, haven't we? So we expected fizz. Good grief. Okay, we expected fizz, and the actual was actual result. So it just makes the test a little bit more readable if we put the parameters the right way around. Okay, so expected fizz, actual 3. So let's get back to the code so you can see what I'm up to better. Okay, so now we need to make that test go green by the simplest means possible. So we can no longer return input.toString, so we have to do something else. So maybe if input modulo 3 is 0, so the modulus operator, if you don't know, is the remainder when the left-hand side is divided by the right-hand side. So if you divide something by 3 and the remainder is 0, that means it's exactly divisible by 3. So input modulo 3 equals 0 means the input is divisible by 3 exactly. So if that, then we can return fizz. And over on the unit tests, they have gone green. There we go. And you probably saw the markers in the margin here go green as well. And oh, look, there's some interesting statistics there I hadn't noticed before. Excellent. All right, so what's our next test? So let's copy that again. So our next theory is numbers divisible by 5 but not 3 should return buzz. So that's 5 and 10. Numbers divisible by 5 but not 3 return buzz. Okay, so we're testing here for buzz. Buzz, okay, and our test, yep, you can see already the red lines in the code here, the red markers in the code here, you can tell that's not working. And in the test window, you see the 2 failing tests. Good. So red-green refactor, so we've had a red test. We now need to make that go green by the simplest means possible. All sins are allowed. And so get FizzBuzz input string. So we need to do a check for if input modulo 5 is 0. So by the same logic, if that's exactly divisible by 5, then we return buzz. Okay. And our test, as you can see, the markers here have gone green, so that test is passing. Now, this is the deal breaker, I think. The next test, if we copy that again, and we want numbers divisible by 3 and 5, return FizzBuzz. Okay, so we'll be looking here for FizzBuzz, Right, why have we got oh, because I've actually done it outside the class, so all this code needs to move up inside the class here. There we go. Let's run a code cleanup to just put all that back into shape. There we go. And oh, we've still got a problem here. Oh, it's all gone horribly wrong. So okay, let's go up to the first error and see what I've done. Right, so get FizzBuzz string does not exist. So what we seem to have done is probably messed up the closing brace of the class. So there, yeah, I've got one too many here now. That closes the namespace. So if we let that go, yep, we're fixed. And our test is back to failing. So now then, there are various, if you look on Stack Overflow and places like that, you'll find various solutions to this problem using various clever coding techniques. But I prefer to just keep it simple, because the important thing is you need to be able to look at the code and just instantly know what it's doing. So if input, I'm just going to put, if it's divisible by 3 equals 0 and input %5 equals 0, then return FizzBuzz. Now, yes, that's not the most efficient way of doing it, because I'm doing a lot of the calculations twice. But you know what? It doesn't matter, because it's going to be like 500 nanoseconds versus 600 nanoseconds, and you cannot tell the difference. So premature optimization is the root of all evil. So just don't do it unless you need to. Make the code readable. Prefer readability over optimization, because I don't know about you, but I can just see what that code does. So however, it hasn't made the test pass. So what's wrong with that then? I bet it's because I haven't changed the data. Yeah, I haven't changed the input data in the test. That's the perils of copy and paste. So we want numbers that are divisible by 3 and 5. So 3 times 5 is 15. So the first one is 15. So when I do that, let's look at the test workspace. Where is it? You can see now that the first one of those tests has passed. Divisible. So numbers divisible by 3 and 5 return FizzBuzz with input of 15. That is now passing, but this one here still got the incorrect input, so it's still failing. So the next number divisible by 3 and 5 is, what was it, 20? Or yeah, 20. Let's try 20. Hang on. 20 is not divisible by 3, so well, 30 definitely is, because it's twice 15. And there we go. And all the tests are now green. We have officially written a fully working and tested version of FizzBuzz. And I'll leave the recording there. And I hope you found that useful. Thank you for watching, and goodbye.